All right, so here's the second part of what it looks like when we're combining transformations. First of all, again, here's all our notes. And then we get down to here, and we can see what's going on. So when we're doing it, again, we sketch the original function, do any stretches, perform any reflections, do any translations. So to try this thing out again, we stretch, we reflect, we translate. So first thing I'm going to do here is stretch. I've got a value of 2, which means vertical stretch factor 2. I've got a b value of 1/2, which means horizontal stretch factor 2. Remember, we always have to do the reciprocal of the b value. My h value, notice how it should be negative here. To make it positive, my h value is -5. What that means is horizontal translation left 5. And then I've got a k value of -8, which means vertical translation down 8. So stretched by a factor of 2, it's going to go to there. No reflections. Then to here. And then left 5, down 8. Now I'm going to do both of those in one piece here. Left 5, down 8. So I'm just going to take this point over here, down to there. There's my vertex. The next nice point was at 2, 2, 2, and -2, 2. So from my vertex, if I go down 8 over 5, that gets me to here. I like to go, okay, that's over 2 and up 2, over 2, up 2. So once I'm from my starting point, I can draw it really quite nicely just by following the correct instructions out of there. So there we go. We've done all of those things in one piece. So my original graph is y equals x squared. Write the equation for this. So the f at something, f at x equals x squared. So as I replace this thing here just goes in place of my x. So that's y equals 2. There's my squared something, plus 8. And what's going to go in there is 1 over half x plus 5. Now, if I put this in my graphing calculator, this is just plain x squared. I can either write it in function notation, 2 times vars y vars function y1 at 1/2 bracket x plus 5, close bracket. I only closed my bracket once, actually. There we go. And then plus 8. So this is the thing that matches this thing, right? y2 equals 2 y1 at 1/2 x plus 5. Plus 8, plus 8. Minus 8. Ha! Good thing I'm paying attention. And then over to here, make that a minus. Or I could go 2 times bracket 1/2, close bracket x plus 5, close bracket, squared plus 8. There's my original function. There's my transformed function. And it's now drawing my other transformed function. I can't. Minus 8. My bad. There we go. So right here, that should be a minus 8 to make it actually match. First one. Second one in function notation, and the third one just graphing straight out. I can't see that third line yet, and the reason is that it's actually right over top of the second line. And if I go to my table, I can see that that's true. If I go y2 and y3, I can see that the tables of values are exactly the same all the way down. Now, sketching this graph, again, I first do stretch, then reflect, then translate. These are the ones that I think you can't do with your calculator. I will show how to trick this with your calculator on a later video, but it can be done. To do it the way they were expecting you to do it, we first have to do our stretches. So this is going to be a stretch by a factor of 2. So this is going to go down to here. That's going to stay the same. It's invariant because it's on the x-axis. 2 times 0 is still 0. 2 times 4 is 8. 2 times 0 is still 0. 2 times 5 is 10. So it's going to be slightly off the page there for a minute. There we go. Now I'm going to reflect it. Vertical reflection. So first it's got a vertical stretch factor 2 and nothing else. No horizontal stretches because there's no b value in the equation. But it does have this handy dandy little vertical reflection there. So now this piece is going to go here, this piece is going to go here, this piece is going to go here, this piece is going to stay where it is. Bing. And then down to negative 10 there. So there's my vertical reflection. And then it's going to translate right 3 and up 1. Up 1. So this point here is going to be at 9, and it's going to be 3 to the right, so it should be right there. This piece here is going to go up 1, 3 right. This piece here, up 1, 3 right. This piece here, up 1, 3 right. Up 1, 3 right. So that should be my final position. Class example 3. What has happened? So we want to create this. This one, they're giving us the description, the vertical description. We need to create the equation. Horizontal stretch by a factor of 4, or 1/4. This is going to be x getting to be 4x. So my a value is just 1, since there is no vertical stretch. And then a vertical translation of 5 units down, no horizontal translation, so -5, like that. Here I have vertical stretch by a factor of 3/5. So my a value is 3/5. A reflection in the y-axis, which is actually a horizontal reflection. Right, here's my y-axis. If I reflect over that, it's actually happening horizontally, so that's going to become negative. And then I need to put brackets around my x, and I'll show you why that is in just a second. Horizontal translation, 2 units left. There. And no vertical translation. So, transformed here, stretched vertically by a factor of 1/4, reflected in the y-axis, translated 3 units to the right. So, again, what I can usually do here is go, okay, well, it's going to be something like this. Right? Now, what I've got here is vertically stretched by a factor of 1/4. So my a value is going to be 0.25, or 1/4 if I preferred fractions. My function is going to be something cubed. My b value, again reflected in the y-axis, my b value is -1. So it's going to be a -1 up front here, and then translated 3 units to the right, x minus 3, and then 3 units to the right. No vertical translation, so that should be my new equation. Now, this is a style of question that you are going to see over and over and over again on basically every test that you see with me, every cumulative exam, probably on your diploma, and this is the hint that you need to follow. This is your rage question. Why is it your rage question? Because you've been given an awful trick question. It looks really straightforward. You're like, yeah, horizontal stretch factor 2, perfect. And then this is +3, so that means left 3. Unfortunately, if you try that, you would get it wrong. Why wrong? This thing's missing its brackets. What they've done is they have gone from what you should see and they have distributed this in on you. So what you really have is bx minus bh. So your h value that you think is your h value isn't really your h value. So that is Alberta Ed / Mr. McManus / whoever else is writing the test trying to steal your points. They're trying to trick you. And you will see it. It's the most common trick question that exists in this course. You're going to see it over and over and over again, and I don't want you to fall for it ever. Rage. You should feel just anger welling up inside of you. And the only way to satiate that anger is to do this. Factor it out. I'm going to factor my b value back out of the situation. And if I do that, this is actually going to become 6. The reason it becomes 6 is that I've divided out 1/2 by 3, or by 3 by 1/2. If I do this here, if I go 3 divided by 1/2, I get 6. People commonly will do that backwards. The thing you can always do to check yourself is to distribute that back in. And that's what I would get there. Okay, so what I do now is it's actually going to move horizontal stretch factor 2, 6 left, and 8 down. So I'm first going to do my horizontal stretch factor. Do that one in red. So all of these things are going to double. So this point here that's at 4 is suddenly going to be at 8. 3 becomes 6. That's that point. -4, -6. So there's my stretched version. And now all I need to do is go 6 left, 8 down. So 2, 3, 4, 5, 6. 8 down should put it about there. 6 over, 8 down should put it there. 6 over, 8 down should put that one right there. And then this one, 6 over, and then 8 down should put it like there-ish. There we go. So that is the trick question to keep your eye out for. We'll come back to that in a little bit.